Recording. Okay, so over here we have, it's called a trigonometric function, right? So function means you will have an input, right? And then an output. So once you have input, output, you create a point, and then you can plot the points. Connecting all the points, then it becomes a graph, okay? So that means you have X and Y, right? So whatever that comes after the sign, right? Here I give you an example. This one represents the angle, right? You always put angle in there. It could be degree, could be radian, right? Degree or radian. Okay, so please write that down. And then once you plug it in, right, you can use the what you learned last time, find the exact value, right? Or you can use calculator, right? And then hit the sign button, then it comes out a ratio, okay? So the answer that comes out, this is called the ratio. Ratio of the sides, right? So it could be exact. For example, like square root 3/2, that's the exact value. Or it could be decimals, right? If it's not special, okay? So here I made up a table of all the input, right? So this one is the angle. This one is the ratio. So look at how I divide it. First, you have 0, right? And then in the middle, you have a pi, right? You can circle those ones. And then in between 0 and pi, you get pi/2, okay? And then pi, next one is 2 pi. So 2 pi makes one circle. So basically, we are finding all the ratios as the angle turns in one circle. Because once after one circle, it starts to repeat the same place again, okay? So for example, the first ratio that we want to find, you can draw the angle on the top, okay? So the first one is saying the angle is 0, so it will be over there, okay? You see a red line, it doesn't open yet. So what will be the ratio if I sub the angle in? William, if we put 0 into sine, what's the answer?
0 into sine.
Yeah, what is sine 0?
Let me see.
Yeah.
0.
Yeah, okay. So this one is the one on the axis. Do you remember? Right? You have to use the 3 cross.
Oh, I
Okay?
see.
Yeah, so because it's starting at 0, so it doesn't open yet. So it will be the one on over here. Okay? So sine 0 equals to 0. Let's go back. So, and then in between power 0 and pi/2, I divided into 2 more points. Okay, so let's also compare with the bottom, right? The horizontal axis is the angle, right? So I put 0, right? And then pi/2 will be right in the middle here. And then pi. What is between pi and 2 pi/2? 2 pi. What's the angle between pi and 2 pi? Tiana? Tiana, you're there?
Pi/4.
You mean pi/4?
Yeah, pi/4.
Pi/4 will be smaller than pi. Okay, my question was between pi and 2 pi, right over here. This one. The one in the middle here. The one is circle. What's the angle right in the middle between pi and 2 pi?
3pi/2.
Yep, very good. 3 pi/2. So it's at 0, right? Pi/2 will be going to the top, right? 90 degree, right? And then keeps on turning. Pi will be the 180 degree, so it goes to there. Okay, and then 3 pi/2 it turns to the bottom. Right? And then 2 pi, it makes one full circle. So after that, it will repeat the whole process again. Okay, so same thing with the bottom axis. We have 0 pi over 2 pi, next one, 3 pi over 2, and then 2 pi. Okay, so I line up the table with the graph. Okay, so we can plot them one by one. And then right in between 0 to pi over 2, there are 2 points. So we cut it into 3 equal parts. Okay, so each one will be pi over 6. And then you add another pi over 6, there will be 2 pi over 6, which is pi over 3. Okay, it came from 2 pi over 6. You can write it over here. Okay, and then 3 pi over 6 will be the pi over 2. Okay, so what is the next one? Let's fill out all the x values first. Okay, so Kelly, what's after pi over 2? The gap between each point is pi over 6. So you have pi over 6, 2 pi over 6, 3 pi over 6. What's the next one?
4 pi over 6?
Yeah, you just keep on adding pi over 6. And 4 pi over 6, we could simplify, right? Into what?
2 pi over 3.
Yeah, okay, and we can reduce the fraction, okay? Next one will be what, Eric?
5 pi over 6.
Yep, 5 pi over 6. So we're making the angle bigger and bigger. And the next one will be 6 pi over 6, which is same as pi, right? And then go on. The next one, William?
7 pi over 6,
Okay.
which
Donna?
is, okay,
Yeah, 7 over 6, you cannot reduce, right?
okay.
4 pi over 3.
4 pi over 3, very good. Okay, so it's like 8 pi over 6, right?
6.
Yeah. And then 9 pi over 6 will simplify as well, right? 9 pi over 6. Let's write that down. This is 8 pi over 6, 9 pi over 6. What's next one, Ray?
10 pi over 6,
Can we reduce that?
5 pi over 3.
Okay, 10 pi over 6 into 5 pi over 3. Okay, last one here. Trudy? Trudy?
Sorry.
Yeah, what's the last one there?
It would be 6 pi over 3. 2. Wait.
We are going up by pi over 6 each time, right? So where's the last spot?
11 pi over 6.
Yeah, okay. And then 11 pi over 6, we cannot reduce that, right? Last one, the very end is 12 pi over 6, and then which turns into 2 pi. Okay, so we are equally spaced out, right? Just like when you make table value for parabola, right? You used to have -2, -1, 0, 1, 2, right? But here we are using angles, right? So that's why it looks a bit harder, right? It has fractions. Okay, so here are the angles. Now we need to get their output, right? So for example, let's pick a random one. Okay, let's say I want to do this one. So sine of 7 pi over 6. So we want to find the ratio. Remember we had 4 steps. What is step 1? Eric? How do we find ratios? Step one is
Check sign.
that's for finding angle.
Draw angle.
Draw angle, yes. Okay. The way you can remember it is if you are given the angle, start with drawing angle, right? If you are supposed to find angle, then you cannot start by drawing angle, right? So we'll draw this out first. 7 pi over 6 means it will turn 1 pi and then a little bit more, right? Remember, you need to write it out in mixed fractions, right? And then we get a triangle there. Okay, so from here, what is step 2 now? After we draw the angle, what is step 2? Kelly?
Find the reference angle.
Yeah, so can you tell me what's the reference angle in that picture?
30 degrees.
In radian?
Pi over 6.
Pi over 6, very good. Okay, so that's pi over 6. So from there, I can write out these sides, right? Pi over 6, it will be 1 root 3 here, and then a 2. Okay, and then we want us to do step 3 now. What is step 3? William? We drew the angle, we got the reference angle. What's the next step?
Draw angle in domain and
No.
wait, what?
We're
Which one are we
finding
doing?
ratio. Find ratio. Find ratio means
Oh.
find exact values.
So wait, what?
Okay, let me show you where to find the notes. Okay, find
Okay.
exact value right here.
What page is that?
41.
Oh, past it. Oh, I see. Reference angle,
Yeah, we did that.
check ratio, check sign. Wait,
So we are on
side ratio.
side ratio. Okay, so what side ratio do we need to write? Let's go back. We want a side ratio, right? Sine is what over what?
Sine is opposite over hypotenuse.
Okay, so what do we put? What over what here?
1 over 2.
Okay, and what is step 4? Keep going.
Check sign.
Okay, so what do you think the sign is? Positive or negative?
Negative,
How do you know?
because it's in quadrant 3.
And quadrant 3, what is positive there?
All students take tangent
Tangent and what else?
and
The flipping. Flipping will keep the same sign.
oh, tangent and cotangent.
Yes, okay, so cotangent and tangent will be positive there, right? And then
Yeah.
so we are doing sine. Sine will be negative. Everything else will be negative. Okay, so this should be a good review, right? I think because we learned how to find exact value like 2 weeks ago. No, 2 classes ago, right? So you probably have forgotten. Last class was backwards, right? We find angle. And before that was finding ratio, right? They are going forward and backwards, all right? So you can use this as an exercise to review how to do the 4 steps. So please fill out all the y values for this table, okay? You can start with pi over 6, okay? So each one you start with drawing angle. pi over 6 will be there, and then you start from there, find the reference angle, get the side ratios, and then check sign. Okay? So when you finish the whole table, please raise your hand. Is there anyone having trouble here? Okay, let me know, then I can go over one more together. Okay, anyone forgot how to do this? Let's check one point. Okay, Elaine, do you have the y value for pi over 6?
Yeah,
What's your answer?
half.
Yep. Okay, anyone doesn't get half, let me know. If you finish the whole table and then you feel that they are all good, right? They are all correct, you can start plotting, okay? Follow the points. So total we will have what? How many? 1, 2, 3, 4, 5, 6. So 12 points, okay? Okay, William, what's your value for pi over 3?
Root 3 over 2.
Okay, very good. And then Eric, what is pi over 2?
1.
Yep. Please raise your hand if you finished or have questions. Let me know. Okay, Donna, what's your answer for 2 pi over 3?
Root 3/2.
Root 3/2. Okay. And Kelly, what's 5/6? Kelly? Kelly, are you there? Okay, Trudy, what's 5/6? What do you have for the ratio?
I have 1/2.
Over 2. Okay, Kelly, are you there? Okay, Samantha, how about pi? What is sine of pi?
Zero.
0, yeah, very good. Okay, and then we did the 7/6. Okay, Tiana, 4/3.
Negative root 3/2.
Mm-hmm. Ray, next one.
-1.
Yeah. William,
Negative root 3/2.
okay. And then you should be able to see the pattern now, right? Kind of symmetrical, like a parabola, right? Left and right look kind of the same. Okay, Donna, next one.
-1/2.
-1/2. And then last one here,
0.
it will be 0. Yeah, go back to 2 pi, right? Because 2 pi and 0 will be the same place, right? Make one circle, go back to the original. So ratio should be the same, okay? All right, so now we just follow the points and plot them, okay? So we have, I'll use red, 0, 0 will be the first point, half, right? So right in the middle of 0 to 1, so right here. Root 3/2, okay? You might need a calculator to find out how big that is, right? What is square root 3 divided by 2? Eric, how big is that?
0.86
0.86.
or
So
87.
almost 0.9 then, right? So it'll
Yeah.
be pretty high up, right? But almost 1, not touching 1. Next one will be exactly 1, so goes to there, goes back down, almost 1, and then to half, and then to 0, right? So you start to see the wave now. That's where the wave come from, right? So we turn a circle, and then the sign can start from 0, goes to 1, go back down to 0. Next one is -half. -half will be at the bottom now, below the x-axis, right? And then -0.9, right, close to 0.9, and then -1, and then -0.9, -half, and back to 0. And after that, it will start to repeat the same thing, right? Because it goes through the same angles, right? Same reference angle again, okay? Even though the angle gets bigger and bigger, but it will repeat the same pattern. So now if we connect, right? So it looks like the graph on your cover page. So this function is called the y equals sine x. Okay, so of course you can do the same thing for cosine x, right? and then tangent x, and also other ones, right? You can just make a table, and then you can start to see the how the wave look like. Okay. Now there are some key points that you can use, right? So then you don't have to make so many points every time, right? Because this is the first time. That's why we did spend a long time, so you get a more detailed graph. But in fact, you could just use the 3 cross. Okay, use the 3 cross to help you remember the key points, right? The key places are 0, pi over 2, right? The ones on axis. So I'm going to highlight the ones that are on axis. So these are the ones that you need to memorize. 0, right? Pi over 2 will be 1. Pi will be 0, right? So you already know those. 3 pi over 2 will be -1. 2 pi will be 0, right? So I will highlight the points on the graph as well. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, you don't need to memorize all the 13 points, right? But at least you have to remember 5 points. The middle point, and the highest point, and the lowest point. Okay? So that's the least you have to remember. So same thing with the cosine, right? Because cosine, we also have the cross, right? We could use the cross there and then try to predict what the graph look like. Make sense? Okay, so let's go to the bottom part. So for sine or cosine or tangent graph, there are some properties you need to know. So the first thing is the domain, okay? So domain is talking about the x value, and the x value here represents the angles. So what do you think the domain is? What kind of x can we use? Anyone? What do you say for the domain? What do you think, William?
I don't know.
Okay. Do you know what's the meaning of domain?
Yeah,
Okay, what is it?
it's like the the area, like the quadrants thing.
The quadrant thing, what do you mean?
I'm not sure.
Is it the x or the y?
It's the x.
X, right? And the x here
Yeah.
it represents the angles, right?
Yeah.
Yeah, okay, so you think about what kind of angle can we use? Can we use positive angles?
Yeah.
Yeah, okay. Can the angles also be negative?
Yes.
Okay. Can the angles be decimals?
Sure.
Yeah, it can be
Real
anything, right?
numbers.
Yes, so we just say all real number. There's no gap, right? There's no x that you cannot sub into the sign, right? We only chose these one because these are the ones that are special. But it doesn't mean angle can only be those ones, right? I could have pi over 7 if I want. But then if you want to find the ratio, you have to use calculator, okay? So I chose these special angles so we can practice the 4 steps, right? So domain here, angle can be anything. So we say all real numbers. Okay, so range, what about the range? Range is the y values, right? And y values, they are the ratios, right? Ratios of the size. So what do you think the range is now? Trudy, what do you think? You can look at the picture. What do you say the range is?
And the y one. I mean in between or equal to 1 and -1.
Yeah, very good. Okay, the highest it can go up is up to 1. The lowest it can go down, right? The wave is to -1. So in between, okay? So remember you put y in the middle. -1 is the lower end. 1 is the higher end you put on the right side. Always open your inequality to the right. And it could also equal, right? To the highest point and lowest point. So that's a range. Okay, now something that's new here is called the amplitude. Okay, so please put a star there. Amplitude. Anybody learn that in other subject? What's amplitude? Have you heard of it in other courses? Eric, have you heard of amplitude?
Is it like the highest point and lowest point in a wave?
Say that one more time. Highest
And lowest point in
highest point and lowest point.
yeah, in a
Yeah.
wave.
Yeah, in a wave. Yeah, something to do with that. Okay. Anyone else want to add to that? Not 100%. I think. Yeah. Related to highest point, lowest point. What else?
Isn't just the height of the wave? Like,
Height of the wave. Yes. Okay. So it tells us how wavy it will go. Okay. I don't know if there's a word. Go wavy, right? So if the amplitude is bigger, the higher it will go, right? The lower it will go. So amplitude is talking about the range between the highest to the middle line. So this is called the amplitude. Or lowest to the middle line. That's also called amplitude. So amplitude is called the height. Okay, how high the wave can wave, right? Oscillate. Okay, oscillate, that's the word, right? So it doesn't have a negative sign, right? It's just how tall the wave is. So in this example, what's the amplitude then? Kelly?
1.
Yeah.
-1.
Well, it won't be -1. Even though it goes down, it's still called that amplitude equal 1. Okay, so amplitude is just the height. You can go up by 1, go down by 1. So amplitude is 1. So you just measure from the middle line, all right? So we can write out a formula for that, okay? Amplitude is you take the highest point, we call that max, minus the minimum point, and then cut in half. Okay, because when you minus the max and min, it finds the total, right? And then you divide by 2, then that gives you half of the total, right? So in this example, will be 1 take away -1, right? Highest is 1, lowest is at -1, right? So 1 minus -1 is 2. 2 divided by 2 will be 1. Okay, for this one. But then later on, you will see we get to change the amplitude. Okay, so you have to remember the formula here. You can box the formula. Okay, any questions so far? Next term is called the period. Okay, so period is, we'll write it down in a sentence. Okay, how long it takes for graph to repeat. Okay, to do the same thing over again. So how long does it take for this graph to repeat? Tiana? How long does it take for this function to repeat the graph? Tiana, are you there? Yeah.
Yeah. I don't know.
Well, look at the picture, right? It keeps going up and goes down, right? And then goes down and then goes up what's gonna happen after that?
Goes up.
Goes up again, right? So it will start to repeat there, right? Make sense?
Yeah.
So how long does it take? What's the total length?
2 pi.
2 pi, yeah. It takes one complete circle to repeat, because if you look at the table, after 2 pi, it will go back to, the ratio will go back to 1/2 and then root 3 over 2, right? And then repeat the same value of ratio again, okay? So the wave will repeat after one full circle, right? So for this one, it will equal to 2 pi. Okay, so this is the period for a regular one, right? If it's not being changed, right? So we call that the original period. Okay, remember we could also do expansion, compression, right? Don't forget your transformation, right? RST. We could do horizontal stretching, then we can change the period, right? Make it longer. Or we can do compression, make it shorter, right? So right now what we have here is the original one. It did not change at all, okay? So later we'll learn about how to change it. So here to here, too long. Here to here, this part, that's the period. Okay, period equal 2 pi for basic. All right, so last one we are looking at the size of space. Okay, so this one is very special because at school you don't have this thing. So I made this one up, okay, so that to help you how to draw the graph more quickly, okay? So size of space is the space between important points. Okay, space between important point. Important points means all the highlighted one, all the yellow ones. Okay, the yellow highlighted ones. So how many points are there? William, how many points are important?
All of them are important.
How many? There are
Um,
only the highlighted ones are important. How many are there?
Oh, 5.
Yes, okay. So remember, for every single graph in this chapter, you have to draw 5 points, okay? So there are 5 points here. It cuts the whole line, right? The string, this red string, into how many pieces? Right? How many sections?
That because my Wi-Fi cut out.
Okay, I'll say one more time, right? We have 5 points, 5 yellow points. It cuts the whole graph into how many equal sections? Did you hear my question, Iray? Iray, are you able to hear my question? Okay, I think her Wi-Fi cut her off. Okay, how about Trudy? Did you hear my question? Did you hear my question?
No, I didn't hear it either.
Okay, I'll say one more time. Okay, we have 5 important points, right?
Mm-hmm.
Okay, so it cuts the whole red line into how many equal sections?
5 sections.
5 sections. Let's count together. Okay, this is 1 section.
Oh, wait. 4 sections, right?
Yes, okay, so we have another one, 2, right? 3, 4. Okay, so 5 points, but it creates 4 equal space. So that's what I mean size of space. So size of space is talking about the space between these important points. So that's the SOS. Okay, so each of the green sections. So we have 1, 2, right? Another one, 3, and then 4. It takes 4 spaces to make a complete period. Okay. Does anyone have questions so far? Right, the whole period will divide into 4 equal lengths, and then that completes the whole section. So each little section is called size of space. So we need to know, so the reason why size of space is very important is if you know the size of space, then you know how to find all the points on the X. Okay, so it's a space between important points. And to find that, we take the period divided by 4, right? Because period is the whole length. You divide it by 4, then you find out how long each space is. Okay, do we have any questions? If you understand everything here, can you raise your hand? Okay, show me hands if you get it, right? Otherwise, let me know, I can explain more. Okay. Iray, you still cannot hear anything? Seems like Iray is having trouble hearing here. Still no? Okay. Let me check, okay? Let me check with her. Can you hear now, Iray? You want to try and, okay. She probably cannot hear it. Can you hear me, Iray? Okay, so this part, these 4 things, okay? So the last 3, these are the new things. I would like you to make stars, okay? Amplitude, period, and size of space. Okay, we're gonna look at those again, okay, as we do more questions. So now before we start transforming, right, there are some basic graph we can draw, right? Remember, we can get the important points from the 3 cross, right? So let's try that here, right? The first one, we just did it. Y equals sine x, okay? So you can draw the cross there. For sine, we know it's 1, -1, right? 0, 0, okay? And then we start from here will be 1, here will be -1. Okay, Iray, can you hear now? Okay, and then we will start from 0. Still not working for it. Okay, so we follow the points. We start from 0, right? 0, 0, right? 0 degree will be here, right? And then pi over 2 will go up to 1. right? And then turns to pi, we'll go back to 0. And 3 pi over 2 will be here. And 2 pi will get back to here, right? So that's one full turn. So you just need to know the important ones, okay? And the important ones is from your 3 cross, okay? So we have the Oreo number here. Range is between 1 and -1, okay? Period is 2 pi for the basic. Okay, so please do the same thing for cosine. And if you finish the cosine graph, please raise your hand. Okay. Okay. Cosine will have 0, 0 in the middle, right? 1 and -1 on the x-axis. So follow the points. Okay, please raise your hand if you have questions or if you finish the graph, cosine graph. Total 5 points. Anyone has questions? Anyone doesn't know how to graph here? Let me know. Okay, Donna, can you tell me where is the first point?
1,
1, very good. Okay. So 0, 1 is the first one.
0, 1,
Yep. Okay, Tiana, where is the second point?
0.
Yep. So pi over 2, 0. Okay. Kelly, do you have the third point?
No,
Do you know how to find the third one?
I'm a little bit confused.
Okay. Do you know how we got the 5 points for the sine?
Kind of. My computer kind of crashed twice.
Yeah, I saw you came in and went out. Okay. So the point, I'll go through one point at a time. Okay. So the first point, 0, 0. Do you see the green circle?
Yeah.
Okay. 0, 0 because the angle is 0 and then the ratio is 0. You see the circle, the green circle on the left.
Mm-hmm.
That's why it's 0. Okay. And then after that, it turns to pi over 2. So that's to the y-axis now, right? So turns 90 degree. So pi over 2 will be the second point. And then the ratio will be 1. So that's why its pi over 2 goes up to 1. You get it?
Yeah.
Okay. Where is the third point?
0.
Yeah, so it goes to 0, and it happens when the angle turns to pi, right? 180 degree. So you get our third point. And then you continue, follow that pattern. Next one will be -1, and then complete the circle will back to 0. Make sense?
Yeah.
Okay, so if you look at the cosine, where is the third point?
-1.
Yeah, very good. Okay, so it'll go down here. And then the next point, William?
0.
Yeah, we'll go to 0. And Trudy, where is the last point?
1.
Yep, it'll go back to 1. And then after that, it will start to repeat the same pattern, right? It'll go back down to 0, and then to -1, back to 0, and go to 1. Now the problem here, the common mistake is when you connect the points, please do not draw a triangle like this, okay? Remember, this is a wave, right? So you have to make it a smooth wave. And then shows which part is opening up, which part is open down, right? So look at this part, 0 to pi, it's open down, right? Pi to 2 pi is open up. So the cosine graph is kind of like starting at a different place, right? Starting from here. You start from open down, half of the open down, and then become open up, and then open down again, okay? So make sure you curve show the curvy, okay? Show the concave. So this one is open down, open up, open up, open down, okay? Instead of straight lines, okay? If you draw straight lines, I have to mark it wrong, okay? So remember that. Okay. Oh, okay, Ray, you can hear now. Okay, that's good. All right, domain. Are you able to speak, Ray? Are you able to turn on your mic?
Well, yeah.
Yeah, okay, welcome back. Okay, good to hear you. Okay, can you tell me the domain?
XER.
Yep, very good. Okay. And range, what's the range, Tiana?
Y is greater or equal to 1.
Greater and equal to 1. Is that what you said?
Yeah.
Okay, do you see the graph higher than 1?
No.
No, right? So it's not greater or equal to 1. It should be what?
Less than.
Yeah, less than equal to 1. But does it go as low, like lower and lower forever?
No.
So where is the lowest place?
-1.
Yeah, so once again, it's also in between, okay? So remember that. For range, cosine and sine, it's always between something. Okay, now the last one here, we have a tangent, right? Tangent is a bit different now. What are the numbers that's on the cross? Okay, if it's 0, the ratio, okay, do you remember what number do we start with?
0.
0, very good. Okay, so start from 0. The next one should be
Undefined.
undefined, yes. Okay, NA. And then back to 0, and then NA, right? You use the letter to remember. AN, right? AN is NA. So it turns, start from 0, become undefined, become 0, become undefined, and back to 0, okay? Undefined means there is no value there. And when that happens, that means we have to draw an asymptote line. Okay, do you remember that in grade 11, we saw some graph with the asymptote line, right? empty space. So at pi over 2, we get asymptote line because it's NA. Okay, and then another place that's also NA is when it reaches 3 pi over 2. So that's over here. Right, this is at pi over 2. This is at 3 pi over 2. Okay, so from 0 to, for the angle from 0 to pi over 2, this is like the first quadrant. Okay, so is tangent positive or negative in the first quadrant? Eric?
Positive.
It will be positive, right? First quadrant, everybody is positive. And then the first point is at 0. So I will start from 0, and then it will start to go positively, higher and higher. Because of asymptote, it can never reach pi over 2. Okay, so this is a very interesting graph, right? Looks very different from all the other two. Sine and cosine is like a variation, right? They are similar, but tangent is completely different. Okay, and then we are going to go to second quadrant now. Okay, at pi, it will be 0. So I have a point there, right? And then in the second quadrant, tangent will be positive or negative. William?
Negative.
Negative, right? So we have to make the curve go down in the second quadrant, right? Pi over 2 to pi, it has to go downwards because of negative. Okay, and then after that, it's gonna repeat the same thing, right? Because we are moving on to the third quadrant, which is a positive place, so go up. Okay, and then back to 2 pi will be 0, right? And it will be in the fourth quadrant, so go down. Right? Over here, let me write it down, right? Here to here, this is a quadrant 1. Quadrant 2. Quadrant 3. Quadrant 4, right? 0 to pi over 2 is the first quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, so one way to look at quadrant is in a circle, right? Or we can lay it out in the horizontally. So that's two different ways to look at angles. Okay? So this one is very special, right? But they don't ask too much about this, but at least you need to know what a tangent graph look like when you see one, right? It must have an asymptote line. All right, so let's look at the domain. So do you think the domain will be the same as other ones? How would you describe the domain here? Anyone wants to try? What's the domain? Would you say real number? What do you think? Anyone? Irae?
X cannot equal pi over 2 and 3 pi over 2.
Yeah, X cannot equal to pi over 2. Okay, I'll write that down. And then 3 pi over 2, right? Between pi over 2 to 3 pi over 2, how far apart? How far apart between the two asymptotes? Can you tell? What's the space? How long is it between the two asymptotes? Donna? Or Eric, anyone? How far apart between the asymptotes?
Pi.
A pi apart, right? Okay, so we can just say x cannot equal to pi over 2 plus n pi. N is integers. Okay, because those two are not the only asymptotes, right? We will have another asymptote if we continue drawing, right? We can continue the next part and then you get another asymptote, right? And then repeat again, right? So there are infinite number of asymptotes. So because of the paper, right, we only did up to 2 pi, okay? So this is how you write out the domain. Okay, and then the range. Range, what do you say about the range then? Okay, Cindy?
Hi.
Hi, okay, what happened?
Oh, I forgot we had class.
Right, okay, I miscounted you, okay, because we had, yeah, anyways, okay, so can you look at the graph and tell us what's the range?
It's 0 to 2 pi.
Range is range about x or the y values.
Oh, x equals all real numbers.
Is range x or y?
Y.
Y, so you would say y is,
Oh, y equals all real numbers.
yes, okay, y is all real number. We are on page 47, okay? So later on, you have to go back and then watch the video for last page, okay?
Okay.
Wait,
Yeah,
Miss, what's
yes, Donna?
N?
The n?
Yeah,
N is the integers. So what that means is if n equal to 1, that means you have pi over 2 plus 1 pi,
why?
okay? Pi over 2 plus 1 pi, okay? Or if n equal to 2, it will be pi over 2 plus 2 pi. So it's adding pi each time. So why we want to do that is because between the asymptote, it's always pi apart, right? And then to get to the next asymptote, you need to add another pi. Make sense?
Okay.
Okay, so that represent all the asymptote. It's not just pi over 2 and 3 pi over 2. Okay, so for domain, we need to write out all the places that x cannot equal to. Got it?
How about the I?
I represent integer.
How about N?
N is this variable. So it's saying that, okay, so probably you don't understand this symbol here, right? Okay, so
Yeah.
this symbol is saying n has to be integer. Okay, belongs to integer. It's an element of integer. That's what it means.
Oh, okay.
Okay, just like YER, right? Y is an element of real number. And then this part is saying n is an element of integers. Got it?
Okay.
Yeah, okay. So this is just simple. And what about a period? How long does it take for the graph to repeat here? Does it also take 2 pi to repeat? How long is the period? Look at the picture. How long does it take? William, what do you think?
Two quadrants, so like pi.
Yes, very good. Okay, so you can look at this part, 2 quadrants, so that will be this section, right? That part looks the same as, it's like a copy of the next part, right? You look at the two green circles, they look exactly the same. So it doesn't take 2 pi to repeat the whole thing, right? So we say the period is only pi, right? So this one is shorter, right? So pi is a very unique graph, right? Different from everyone else. So here pi is the period. Cosine has the same period, 2 pi, okay? Same as sine. All right, so here are the 3 graphs, but today we're gonna only focus on sine and cosine, okay? That's the main focus. So probably all the graphing, 90% will be on sine, cosine, 10% will be about tangent, okay? So very little question about tangent graph, but you need to know at least how to write the domain out, right? How the graph look like. If they give you one, right, you should recognize it. Okay, any questions so far? I think we'll take a break first, okay? After the break, we'll start to do transformation, okay? So that's why I said chapter 1 is very important. Doing the RST, getting the story form, is gonna help you over here, right? How to transform the graph. Okay, so we'll have a break until 6:28, okay? So I'll see you in 15 minutes.